Welcome to another episode of Percona Live. Here's another talk about Vitess with integrating best-of-breed open source tools with Vitess. And our subject is Orchestrator for today. A little bit about myself. I'm a senior technical manager at PlanetScale. I'm one of the maintainers of Vitess open source project. And I'm an open source database evangelist, previously working at Percona, Python, and other enterprise background. I am also an emit sailor, and if you want to talk about sailing, please do find me. A little bit of PlanetScale background. It was founded by co-creators of Vitess in 2018, and maybe we're a little over 50 employees right now. HQ is in California, but it's a 100% remote team at this point. So going back to Vitess, Vitess is a database clustering system. It's meant for horizontally scaling of MySQL, and it was handed over to CNCF, and CNCF, it's a CNCF graduated project. It's an open source license in Apache 2.0, and it has contributors around the world and the community, and it is written in Golang. So its primary language is Go. And currently, this project is owned by CNCF, and that's important note that I have to mention over here. Today's agenda for this talk will be just for those who are not familiar with the Vitess architecture, and some examples for Vitess use cases, quick examples, and then the focus will be the open source tools that are integrated around Vitess framework. So those are ExtraBackup. As we know, it's a very popular backup and recovery tool, and online schema change tools by Percona and GitHub Ghost, and Orchestrator is our subject. So if you go back to Vitess architecture basics, we want to highlight a few things over here. There's some terminology around Vitess, how it handles. There's a key space, a logical database, because you may shard your database and it needs different key spaces, and it's identified by an ID, and it creates a Vitess index. We call it a Vindex, and there's a primary and different Vindexes that how you shard your database. There's a VT gate component that's actually a proxy server. There's a VT tablet, it's a backend server, and the topology configuration. So if you consider a common replication cluster, each MySQL server will be assigned to a VT tablet, and it acts like a daemon, a sidecar, and it controls the MySQL D process, interacts with the MySQL D server, and usually installed within the same server as the MySQL running. VT tablet is not a very heavy resource consumption in the Vitess world, so it's okay to have a same server as MySQL. Usually we don't recommend running something else within the MySQL server, but in this case it's okay. So in production you will have multiple clusters, and you need some sort of a proxy to access your cluster, and VT-gate is actually a Vitess component, and it's also written in Go, and it's a very smart and stateless proxy server, and it speaks MySQL protocol, and it acts like a MySQL server to a client, and it relays the queries, which means actually it manipulates the queries, and it understands where the data relies on, and in a large Vitess implementation, you may have multiple VT-gate servers running to scale out multiple clusters of your implementation. So if your application connects to VT-gate, it actually routes the traffic. So in our scenario over here, as you can see on the right hand side, we have two type of clusters implemented in total of three clusters. One is sharded and one is unsharded. So this is a typical scenario that you don't actually have to shard all your key spaces, and you may have a mix and match of implementation. And in that case, VTgate type of proxy will know what data relies on which cluster. So query routing has to happen within the VTgate component to access schema and sharding schemes. So this example is a very nice example that we actually always use. The commerce database has different shards based on the customer ID, and then VTgate knows when you send a select statement, it knows where your data sits. So Topo is another component that we actually have it in the Vitess architecture, and it's a distributed key value store, and it's storing information about the schema shard and the tablets, also roles. Topology implementation could be different implementations, which is etcd, console, or zookeeper, and very small data set, and it's mostly cached by the VTgate. So it's actually another component within the Vitess architecture that has to exist to know where everybody else is. So it's actually a repository. VTCTLD is a control daemon. So everything else is controlling something else, and VTCTLD controlling some of the operations. We call it a cluster management, and actually when it does a cluster management, it writes back to Topo. Topo is the repository. So Topology Server, let's say it's an etcd, knows what's happening within the cluster. If it's the tablet is read only, the tablet is down, or something else is happening, everything else within that cluster management operation is controlled by VTCTLD control daemon. So Vitess knows the state of the environment with the schema, shard clusters, and everything else. So Vitess control plane includes, in summary, is a proxy server, a VTgate, a managed backup and recovery, and integrated failover, and which is our subject today, and sharding schemes, and then also it has another component called vReplication and vStream, and it has its own replication method that implements within the sharded implementation, because normal replication may or may not work for that type of implementation, and then also provides online DDL options and more. So we're gonna look into the summary of this implementation. If you put all those back into the Vitess, it is basically compiled of many components and many important components that drives the MySQL in the backend. So the MySQL is still the good old MySQL, and we have another layer in front of MySQL as Vitess architecture. So it is supported in the 5.7 and 8.0, and it was tested until MariaDB 10.3, and it does not have a PostgreSQL support, and Postgres support is not on the roadmap for the near term right now. So there are use cases for sharding, but also there are unsharded usage is also available. As we mentioned in many of these control plane components, that having Vitess in front of your MySQL topology is still advantageous. So you can still manage your MySQL topology with Vitess, and that way you also have ability to shard in the future, or prepare for a sharded environment, prepare to scale out, but still take advantage of other other components. So let's go back to the open source tools that Vitess integrated. So ExtraBackup is already integrated in by Percona, and it's actually supported by the latest versions. Online schema change, PT online schema change, part of the Percona toolkit. If you have it installed, you can actually drive PT online schema change, as well as the Ghost by GitHub, and the Orchestrator is something that is still in progress. I don't think it is tagged as GA or production ready, but this is something that I wanted to talk about because it is very interesting to incorporate these great open source tools into another open source implementation to make it even better. And so we know ExtraBackup is already built in, and it's not compatible with MariaDB 10.3, but MySQL 5.7.8 is perfectly fine. And as you can see, Vitess actually has its own command line utilities, and you could call it a wrapper or other methods. It's actually can do backup and recovery using even in a sharded environment and with arguments. So we have a vtctl command, and then you parse the arguments and you can drive that. Online schema change, we are supporting since version 9. And it has a very advanced implementation within the Vitess. So we actually set the DDL strategy, and then if the DDL strategy is a PT online schema change, you can parse the arguments, and then in MySQL you run the command, and it will actually, Vitess will understand that you want to use PT online schema change in the backend, and then execute the your DDL using the online schema change. So I've put in some examples over here. There are more in the documents. Please have a look. This is super exciting and interesting, which Shlomi is going to talk about at this conference. And same as Ghost. And we actually can have a ghost as an option, and so the pros and cons of between the different utilities exist, and whatever works for different implementations of your cluster, you can choose to have different utility. So we have integrated Ghost as well as a DDL strategy to make your DDL changes using Ghost within the so it's actually very interesting to have these options using DDL strategy. So there's a very comprehensive documentation about this. So we also have online or using vReplication, right, which I mentioned. Vitess has the vReplication component, which actually handles replication within the sharded and unsharded realm of Vitess topology. So we can actually drive using the vReplication, which gives it some additional benefits off of the other options, as well as the Ghost and online schema, PT online schema change tool. So there's more about this in the documentation. Please have a look how it actually can be possible to use these variant of different DDL strategies within the Vitess. And we very much value online schema changes and operations of that within the Vitess. So going back to Orchestrator, we call it a Vtorc, as the naming convention goes with the VT, Vitess, and Orchestrator. It is still an experimental, so there is development in progress, and we need contributors who actually have different cases for Orchestrator along with Vitess, and please do reach out to me or the other Vitess maintainers if you would like to contribute how you can help to more even testing and experimental implementations of Orchestrator. One of the things that when you actually implement a case and you don't have a real use case, it is difficult to mimic the production environments. So going back to Orchestrator highlights, it is developed by Shlomi. He's my colleague at PlanetScale, and is a well-known contributor to open source community, and the tool is very well tested and used in production in several places. So it also has several contributors if you check the GitHub repository, and what it does is MySQL replication topology management, and it actually does it acts as a high availability solution for those implementations. And it actually has a very nice web GUI interface, and it provides HTTP API, and it does multiple things like discovery, refactoring, and recovery, which we will actually demonstrate within the Vitess world. So the next up is the demo. So in this demo section, I want to demonstrate something with the operator. So being part of the operator, it's a little different than normal implementations. So I want to put a disclaimer, safe harbor, deep note over here. There will be 3 different actors in cluster management, and you have to think carefully how you want to test this, because the operators have its own cluster management within the Kubernetes implementation. And then we also have Vitess. Vitess actually does a lot of management of underlying MySQL topology due to the implementation or design of the sharding options. It has to do some management because it needs to know where things are. And then we're actually adding an orchestrator for more. Why are we adding orchestrator, or why do we think orchestrator is needed while we already have a operator and the Vitess? Because orchestrator makes better schema, better topology management when it comes to high availability. So it's the failover scenarios. Things are not safe, or things are actually not looking good. It actually handles those scenarios better. So this is the example. So in our examples operator directory, we have a Vtorc example, and we can actually quickly install this to our Kubernetes cluster, which I already created to save some time. And and then this will create us a sample cluster. So basically what this does in our test demo here is going to give us 1 primary and 3 replicas, and that's the only thing I changed, to add more replicas so that we can actually represent in the Vitess Orchestrator implementation. So these are actually creating real quick, and then as soon as they come up, we will have a cluster ready for serving. Okay, they're already come up. So the other thing is we need to do is the port forward. So since I'm on a local machine and this is on a Google Cloud, I need to make some port forwards. In this example, we have an port forward.sh in the same directory, which actually have different ports for VTCTLD, Orchestrator, and then we set these aliases to access our cluster. So these are required for VTCTL client for the local host that actually points to this cluster, and you know where it goes. It goes to VTGate, and the VTGate knows where the cluster is, and then the MySQL actually is the same thing that actually points to that. And if we have refresh the screen and VTCTLD, let's see what okay, this example, it actually has the commerce implementation, which is uncharted at this point. I mean, you can follow the instructions on the demo site and see the sharded implementation, but we will keep it short over here for this. and then you will see this cluster, and then same as the orchestrator. So if we point to localhost 3, and it knows this environment. Here we go. So the orchestrator is our cluster management, and along with the Vitess, we have this one primary and 3 replicas represented over here. What we can do with Vitess is of course do a few things, but I want to show real quick is so with MySQL there's a different command called show Vitess tablets, and of course this goes to vtgate, and it knows the primary, and then the replicas are attached. And if we actually have the orchestrator is the same structure as the Vitess cluster is. So this is read write, and these are read only replicas with since there is no load, there's no lag, and it shows 0 lag, and everything else is basically. So the other thing is I wanted to show over here with the Vitess we can actually have access to the cluster. So we have Vitess Client, which is actually points to our port forward, the local host, and then it actually acts like a command line interface. So we can do a bunch of things like cluster management, but going back to the orchestrator, let's demonstrate something, and we will do a planned reparent. So what we can do is drag and drop over here, and I want to promote this replica 331 with the IP address as a master. So it will give us a warning, and I can do that, and it will promote that as a master. So what it did, orchestrator, and took that as promoted as master, and it took that other host as took it out of the cluster, and basically and then promoted everything back and converted into. So we can see there was previously a replica over here. Now it became the primary. That replica became a primary in our cluster, and they worked perfectly fine. And this is one thing I wanted to show. But if we didn't have the orchestrator management over here, what would happen in that case if we take the global recoveries disabled, and then we take one of the other replicas and then promote as a master. So I'm gonna show you something also different than your regular command line utilities over here with the MySQL. We're gonna use Vitess command line again, and then I'm gonna execute table externally reparented. Not gonna use the same tablet was previously a master, but I will use something else. Let's take this tablet and then promote as a primary in this cluster. And then now it took the other one out, and then take this newly promoted tablet into a primary, and it took that away. So what would happen in the orchestrator side? This is because we did take the global recovery is disabled. The orchestrator, we told orchestrator not to do anything, so it actually took that master off of that, which was a replica of the previous master over here, and that primary became this. So the cluster is actually still healthy, but on the Vitess world, that previous one is not serving, and the primary has changed because we forced it to change. Okay, there could be many reasons to do that, but so I'm gonna put the global recovery is enabled over here, and then see what happens. So it actually orchestrator actually recognized the dead master, and then it actually wants to recover that. I'm going to refresh over here real quick, and then the cluster is back in business, and then see what happens over here. And now the cluster is back to the serving, and that replica that was not serving, it became a replica of previously promoted primary. So that's another scenario that how the Vitess and the orchestrator actually acted in this implementation. The other things that I can show over here with the time permitting, we take the we will tell not to do anything on the orchestrator side back again, and then we will do one thing. Let's make one of the hosts. Let's take the primary and force it to become read only. What will happen? Okay. So our primary is actually read, right? So what will happen over here is actually nothing will happen. This is the thing. If we were to tail on the logs, this will convert the primary serving in this cluster within the Vitess back to read only off, because it cannot be read only on, and the cluster will not accept that. So that's another thing. And nothing happened in the orchestrator. So the other nice thing about this GUI, we could say read only is false, and then you can not do that within the Vitess. While we're here, let's take that one and set the read only on for that primary. And as you can see, if we did that, we would still not actually be able to force that, because the Vitess will interfere and convert that back into the read write. Okay. So there are some other scenarios that we can do, but what I wanted to highlight over here is the we are actually playing around with the Kubernetes Operator, which actually does lots of management. And if I were to kill one of the pods or delete one of the pods, it will actually you could test this out with the open source Vitess Operator again. If I knock one of these pods off, and you know, the operator will actually bring up another one, reattach itself, and then start serving. So it will do things. The other thing is Vitess does some management over here by, you know, setting a read only, setting a serving, not serving, and all of that. And also we have the orchestrator, which actually does a little bit more intelligent management of the cluster. So let's take one more quick example. What I'm going to do is, since the global recovery is off, and I will stop this replication. Okay, you could do this on the command line by attaching yourself to the backend MySQL in the real world, right? And I am going to do this within the orchestrator just to demonstrate that orchestrator can actually do these kind of things, and then reset this replica. Okay. So what happened is this replica became detached from our cluster, and our cluster is still serving one primary with two replicas. And then if we were to actually look at the Vitess side, Vitess also recognized this replica is kind of out of sync at this point, and not serving immediately. So these things actually happen automatically in the backend, where if things were to go wrong, you're not actually reading from that replica. There's no like a stale data that can happen. Okay, so what I will do is just to turn on the global recovery is on back again, and just to demonstrate that it will automatically recover that and then attach it itself. Of course, these may take some time in real production with the load on, as these are happening instantaneously over here, that you can see that things are back in business. And thank you very much for watching this session, and please reach out to Vitess maintainers. Come on Vitess Slack, and if you want if you want to talk about Vitess and ask questions about the utilities that we presented today, and happy to answer questions. Thank you very much.